what I'm going to do is to go back and pick up where Marcin Kucharek left off. So his introduction to nuclear physics was very brief, and that's good because I don't know enough to say anything more than that. I guess everyone knows that atoms have a cloud of electrons around a core, a very small central core, the nucleus of the atom. And that's positively charged. And it consists of a mixture of two, I'm just repeating stuff you all know, but just so we know where to start. The nucleus consists of two kinds of particles, protons and neutrons, more or less the same weight. The number of protons determines what kind of atom it is. And so, and some atoms are radioactive, which we discussed a little bit last time, and some are not. So these are all just background bits of information. Okay. So the positive charge of the atom is concentrated in this very small core, the nucleus, which is relatively heavy. The electrons, of course, are very light, and they're some distance away. In uranium, which figures largely in the story of weapons, there are 92 protons in the core, and and there are also lots of neutrons, of course, without any charge. And the common isotope of uranium is uranium-238. So that means it has 92 protons, as I said, and the rest of the 238 nucleons are the neutrons. And various arrangements could happen, but there are only two common uranium isotopes normally, and that's uranium-238, which is common. It's 99.3% of the uranium one digs up. And there's also a little bit of uranium-235, 0.7% of it, and that's the one that's key from the standpoint of making weapons. So, okay. Do I need to say anything more about this? If you have uranium and it divides up, process of fission, induced somehow or other, then it might break up, for example, into krypton and barium. Together, these have the same number of protons as the original uranium did. And so you would expect, if you could weigh the nuclei for the uranium you started with, and also that which was produced, the molecules, atoms that were produced from it in such a process, you would expect the weight to be the same, but it's not true. That doesn't take account of the possibility of interactions in the nucleus. And so what you find is that the mass of the two separate atoms tends to be the average of it, say, tends to be lower. They aren't as heavy as you would expect them to be in this case, and that corresponds to the separated ones being more stable, that being a more stable situation than the original one. And so that's critical because because that difference in mass that you see there turns up as energy in the process. And under the famous Einstein rule, E equals mc squared. If the mass difference from being simple sum here get multiplied by c squared, and you find out what the energy is. What was noticed a long time ago now was that you could form chain reactions sometimes. And uranium is a good case in point. If you fire neutrons into it, it will, providing other physical situations right, it will react, split up into smaller atoms because that's more stable, and give off more neutrons. And if you're getting more than one neutron off in the result, then you're gaining. You had more neutrons than you started with. And so then the process will keep going, and indeed will multiply its speed very rapidly. And that's the chain reaction explosion of uranium, which is crucial. Let me start then. In 1940, Otto Fission and Rudolf Peierls, who were refugees from Germany, basically from Germany, in England at Birmingham, were working on this question of whether you could gain energy from the fission of uranium. And it finally occurred to them, which was the key fact, that the uranium-235, which I've already mentioned, which is present in very small amounts, under 1%, reacts much more readily with neutrons to produce smaller ions and possibly more neutrons. And so what had looked like an impossible job of getting this chain reaction going in uranium, they realized would work well if you used just uranium-235, because it was much more reactive with the neutrons, and so the thing would proceed well. And so they decided that a bomb based on the chain reaction using essentially pure uranium-235 looked quite possible. And they wrote a memorandum on this subject, which they gave to the British government, who hid it from themselves and others for a while, and so on. But eventually, the information was shared with the United States. And Roosevelt, by then the United States had entered the Second World War, and Roosevelt studied this matter, and others did, and they decided that they should try to make this scheme work, make an explosive in this way. And the project of trying to get that to happen was called the Manhattan Project, centered mostly in Los Alamos and other places out west. And the project was run by Robert Oppenheimer, who was the scientific leader, and General Graves, who was a military man and the sort of administrative manager. And they were both very powerful in this, but they couldn't get along with each other. Indeed, Groves was a real hawk, as we came later to call him, and Oppenheimer closer to a dove. And so that was made for exciting times. Anyway, they needed almost pure uranium-235, something like 99%. And so they had to separate they had to separate the uranium-235 from the uranium-238, and that was a big job, very slow to do. You can see that you can differentiate them. For example, if they diffuse, one of the weights will diffuse more rapidly than the other, And if you did that successively, eventually you would get a very small amount of the one that diffused more quickly out. So that would be one way to do it, or you could use a centrifuge over and over and over again. But you see, each stage of these separations would be very slim because the difference between 235 and 238 is not very big. So, so that means that it took them a long time to actually do the concentration of the uranium necessary. Indeed, a couple of years, really. And finally, in any case, they did it, and they were able to set up the possibility of having an explosion, of having a bomb, if you like, of provoking such an explosion. And then the question was, should they do it? Of course, they already knew that it would be a tremendously powerful bomb. And so it was apt to do a lot of damage. And so there was some move that they should just suppress the whole thing and not let it out. But that wasn't accepted, and indeed even Oppenheimer was not willing to do that. The worry was, you see, that the Second World War was still on, that the Nazis in Germany were behaving in completely unpardonable ways, without any mercy for the Jews and for many others. And the fear was that the Germans, who after all had started this line of research on nuclear more than any other place, that they would notice that you could make a powerful explosive and do so, and would be able to impose it on the world if there was no counter. So the idea was, no, we must go ahead and explode this so that they can't do that, so that there's a deterrent to behaving that way. And so the decision was finally to go ahead and try it. And so they first of all did a test in the desert at Alamogordo, New Mexico. It was actually a slightly different design of bomb, but it's the same idea. And then they decided, yes, they would go ahead and drop this bomb on a city in Japan, Hiroshima, of course. And they did so in August. And it was a terrible thing in a way. The town was obliterated. You've probably all seen pictures of it. There was nothing left standing except the odd bit of reinforced concrete here and there. And it was terrible carnage. It killed most people immediately. They were the lucky ones. The ones that weren't killed immediately died from radiation sickness and other problems, from wounds, from the debris that had been flying around, and burns. Many of them, the skin had skin peeling off from the burns. Most of them, anyone in the neighborhood, in the region, who was around had been blinded, because if you looked at the mushroom cloud, you would quickly get blinded by ultraviolet rays and so on, and so on. So it's a very sad story that this very small atomic bomb could have made such carnage. Very small is interesting. It was a bomb of 13. I guess I can't use the blackboard now. It was a bomb of 13 kilotons. That is, it had a blast equivalent to that of 13,000 tons of TNT equivalent. So, so think about that. This was just a little device with a few pounds of uranium and so on. It It was not anything very serious, you would think, but it had all this tremendous explosive power. I mean, if you think of TNT or other conventional explosives, you know, if you want to carve up some granite to put a highway through or something like that, you only need a little bit. You drill a bunch of holes and you put a little bit in each and they go bang and the thing flies apart. That's from, so a few pounds at most of conventional explosive. Here we're talking about tons, and we're talking about 13,000 tons. So you should keep in mind that we're now looking at tremendous amounts of blast and energy. So they were somewhat appalled, but nevertheless the decision was to go ahead and drop a second bomb on Nagasaki, which they did with similar results. And then there was a hope, a flurry of hope, I've called it, that we could spare ourselves the future that this implied. And so let's think about that for a few moments. The United Nations Charter had just been signed, and the first meeting of the General Assembly was held in the following January. At the same time, the Cold War was starting. The Cold War is a subject of its own, of course, but it was bitter from the start between the States and the Soviet Union, Soviet Socialist Republics. And so the Cold War entered into all the decisions which were implied by these things. The first resolution to come before the General Assembly of the United Nations, number 11, was to set up the United Nations Atomic Energy Commission. And that passed by a unanimous vote. And then it was in place to take nuclear matters for decisions and discussion. Atchison and Lilienthal. Atchison was a former Secretary of State of the United States. Lilienthal was chairman of the Tennessee Valley Authority. And they wrote a report with Oppenheimer's help, said to be largely due to Oppenheimer, which attempted to make the control of weapon-grade materials international control. So this was going to come before the United Nations Atomic Energy Commission. However, the president, Truman by this time, Roosevelt having died, chose a financier, Bernard Baruch, to present an altered version of the Atchison-Lilienthal report. And he altered it in very serious ways, which meant that it didn't finally pass. The proposal, as submitted to the United Nations, was that there should be an atomic development authority to oversee the development and use of atomic energy, that it should manage any installation that could build weapons, and simply inspect others who did research for peaceful purposes, just to check that that's what they were doing. Any violations were to be punished in serious ways, and that punishment was not subject to veto as other things were to be. So it meant that those who ran the Security Council would have an enormous amount of influence on what happened to people who did things that, in practice, the Americans didn't like, since the Americans and their friends controlled the Security Council pretty well. And there was no attempt to get the United States to begin destroying its arsenal until all the other control things were in place. So that meant they could go ahead improving their weapons and so on. So that was completely unacceptable, in fact, as you would expect. And, and one could say, I think, that that proposal for the UN was designed to fail, which it did because of the 12 members on the United Nations Atomic Energy Commission, only 2, USSR and Poland, were able to bring it to a complete halt, this plan. All they had to do was not vote, because it required unanimous consent. The United Kingdom also was opposed to the Baruch plan as compared with the earlier versions. Okay. But anyways, this left the United States with its weapon monopoly, as it had had for the moment. It could go ahead developing ever worse weapons and so on. Gromyko from the USSR represented the USSR on the committee, and he proposed an alternative that all the existing weapons should be destroyed and no production proceeded with, leaving the details of control procedures to later, because the trouble with the Baruch plan was really that another problem with it was that it set off from the start putting in punitive controls, and the stopping the canceling the building of missiles and designing of them and so on wasn't necessary until all the rest of the apparatus had been put in place. This was an ongoing trouble between USSR and the Western nations, because they had different view of what the order ought to be between control and destruction. Okay. So there was that hopeful stage where people saw that we'd be far better off without these weapons, and tried to achieve that, and it broke down. And so one reverted to the Cold War and the arms race associated with it. But in 1949, the Soviet set off an atomic explosion of their own. So now both sides had a weapon. This amazed the United States, which had expected them to need much longer to catch up. It's true that they may have been helped by some spies, and there's this old story of the various spies, the Fuchs and the Rosenbergs and so on, believed to be spies, and so on. But at any rate, it's what happened. And so the United States, being shocked, thought maybe they'd better make some step of their own. And so they raised the question of making a hydrogen bomb. Hydrogen bomb is different from the kind of bombs we've been discussing, the ordinary atomic bomb. The ordinary atomic bomb is based on fission of uranium or some such thing, divides up and you get energy back. But the most stable nuclei are not at either end of the range, but in the middle. And so hydrogen, for example, is less stable from this energetic standpoint than heavier atoms. And so it should be possible to provoke a fusion bomb in which the hydrogens combine to give heavier nuclei. And the question was whether to go ahead with trying to make such a device. And once again, there was this debate between the principles of Oppenheimer and Groves, for example. But they both thought that one should go ahead finally, because they were not satisfied that it was safe to do otherwise, really. Anyway, and the American President, Truman, also urged the step and essentially ordered them to go ahead. This is interesting. This is what's called a thermonuclear bomb. As I say, in order to get the hydrogens, heavy hydrogens, what you use, deuterium, in order to get them to react, you have to force them together, and you need high temperatures, very high temperatures. And so the question is, how could you do that? And the answer is, you make an ordinary fission bomb, such as the uranium one, and you have it explode and use it, in short, to heat up the hydrogen so that it would react. And so that's fission, a fission explosion driving a fusion explosion. And so that was the idea, and it worked. In 1951, the Americans were able to induce a small hydrogen explosion. And in 1952, they were able to do a much larger explosion. This was still not a bomb, actually. And the reason was that you had to keep the hydrogen liquid as long as possible and don't let it escape. And it was hard to do with gas. And so they wanted to have this stuff initially, the hydrogen, as a liquid, not a gas. And so I think there was 8 tons of refrigeration equipment necessary to provide this, which wasn't portable enough to make a bomb from it, evidently. But anyway, the process worked, and eventually they set off an even bigger weapon, this time really a weapon, because it had occurred to them that if they didn't use deuterium itself, but lithium deuteride, then it would stay in liquid form much more easily. And so they did, in 1954, there was this famous explosion of a test nuclear bomb, nuclear fusion bomb at the Bikini Atoll. And it was the most enormous blast. It amounted to something like 1,000. It amounted to something like 1,000 Hiroshimas. So we're looking at millions of pounds, millions of tons, in fact, of TNT as the equivalent. And so that was a tremendous success. It has to be admitted, however, that the Soviets had, in the meanwhile, probably, it was interpreted that they had set off a fusion explosion of their own, and so they were, in fact, catching up. So that was a big success. The one sad part of it was that fallout, the wind changed, and fallout from the nuclear explosion fell on a Japanese fishing boat called the Lucky Dragon. And that created such anguish and sadness and desperation that the peace movement started in earnest at that point. Russell formed the Campaign for Nuclear Disarmament, and Pugwash shortly came into existence, and so on. So the political atmosphere changed once again. Now, this actually turned in, though, to an optimistic moment, another optimistic moment. The Baruch plan had failed, and that was the most optimistic moment, perhaps. But this was a surprising situation. At the height of the Cold War, if you like, that this should have happened. What happened was that Britain and France submitted to the Atomic Energy Commission. It was a subcommittee of the Disarmament Commission. Submitted to them a comprehensive scheme, an ambitious scheme for general and complete disarmament. That is not only nuclear weapons, but everything. And so that was the idea, and it combined the Western nations' preference for having control measures in place immediately with a proposal for the prohibition of manufacture of nuclear weapons, immediate prohibition, closer to the Soviet view. So it was more popular. And at the General Assembly, the Soviets surprised everybody by accepting the plan as a basis for negotiation. And the United States reciprocated. They proposed specific force levels and verification schemes for prohibiting nuclear weapons. So they were to be prohibited as soon as 75% of the conventional troop reductions had been made. So there was a timetable for actually proceeding with complete disarmament. And so there was a lot of optimism. So 1955, so that looked very good up to this point. 1955, on the 9th of May, West Germany joined NATO, which, of course, would not have pleased the Soviet Union. But anyway, in spite of that, the Soviet Union accepted the force levels and program for linked conventional and nuclear disarmament that had been proposed by the Americans, accepting for the first time the principle of an international control and verification, and preparing detailed scheme for implementation, setting up UN observer posts and whatever. And so anyway, the Soviets went along with all this, and they also proposed the immediate ban on any testing of bombs, and so on. And they set out a detailed timetable, or at least a detailed timetable was set out for 1956 and 57. As a first step, there was to be a 50% reduction of conventional forces in 1956. And that would go up to 100% by the end of 1957, at which time the nuclear weapons were all supposed to have been dismantled. So it was a moment of genuine hope that one might get this entirely new and hopeful situation. But it wasn't to happen. And the Americans seem to have scotched this, so it's very sad. At the Geneva summit of the leaders, of world leaders in the summer, Eisenhower proposed that control should be not by the scheme which had been originally suggested, but by aerial photography. Once again, the Soviets thought that they were being spied on, that was the point of such a policy, and so they were unhappy with that. Eisenhower eventually gave in and said, all right, well, let's have a mixture of the two kinds. But almost immediately after that, Harold Stassen, who was the US rep to this meeting, vetoed the whole process by officially withdrawing all of its pre-Geneva substantive positions. So they just vetoed the whole works, shut it down. So it seems to me one of the saddest things in this whole story, because it was clear that as time progressed and more people built weapons and different people with different interests, it was going to get more and more difficult to eliminate nuclear weapons. And this was a very hopeful looking chance, in fact. And in spite of the fact, well, I guess I've asked here why, the US had concluded that the USSR was building a massive fleet of long-range bombers. It wasn't true, as it happens, and I can't see why that would have caused them to oppose it in any case. And the Americans were being regarded around the world as having been beaten by proxy Soviet troops in North Korea, in Korea, the Korean War. And so their feelings were hurt and so on. So presumably those things were driving the American influence. But even so, even in spite of all those negative things happening from the Soviet standpoint, immediately after the summit, they unilaterally reduced their forces by 640,000 men. They removed their troops from Finland, and they recognized West Germany. However, it didn't matter at all. The Americans didn't budge, and the whole thing died. Rather dramatically, the situation throughout the world turned bad because, partly, I guess, because of disappointment or chagrin at this. The Americans withdrew their funding for the S1 dam in Egypt. There was a glimmer of life in Hungary, and the Soviets in 1956, as we all know, marched into Hungary and treated them very badly, and this crackdown was serious. And the France and Britain attacked Suez, and so on. I mean, the whole situation quickly became very bad. So, okay, I wanted to go over that because it seems to me such a anguishing thing. All right, then let me just mention some other things quickly, and we can discuss them if we feel like it in the question period. The basic question is, why have we got these weapons? What good are they? Are they serving anyone's purposes, in fact? It seems not, because you can't achieve anything with them. All you can do with nuclear weapons is to keep them from exploding. And it's a strange role for a weapon, really. But that is the situation. Because in wars of an old-fashioned sort, I mean, somebody won them, or at least they came to an end and they resolved some issues. Not a very happy way to resolve issues, but at least there was a purpose to it. But having these weapons destroyed the whole value of war, if you like. So I think that we might debate what use there is. What good have these weapons done to any country, for example? Why would anyone want them? Only one nation, namely South Africa, had nuclear weapons and then said no and destroyed them. Nothing bad happened. Indeed, for the most part, they're totally useless and therefore aren't affecting what goes on very much, except inhibiting people from taking strong positions. So I think you have to ask whether there's any point to them. There are certainly dangers because things might blow up into a nasty situation very easily. The Cuban Missile Crisis is worth reflecting on in that context. 1962, Khrushchev and John F. Kennedy. And that was a very serious situation. I mean, they were super stupid to have gone ahead and put the missiles in Cuba to begin with, but it made an unhappy and very dangerous situation. And the other thing that can happen is that deterrence stops. I mean, the only thing that stabilizes the world with nuclear weapons in it is the fear that should you fire on your neighbor, they will fire back. And with these weapons, it's all or nothing. I mean, this is not like ordinary battles where you lose a few tanks and then you go on with it. This means a qualitative change in the situation when something happens. And so a lot of the efforts of trying to manage the world now consist of managing it so that nothing happens with the weapons. If you have, I mean, there's the question of first strikes. People worry that someone will send a first strike on someone else. And what you have to do is to make sure that you have reserve forces which cannot easily be affected by such a strike, so that you could strike back. And the world will be in a terrible state, of course, very quickly. But that's about all you can do. And so the situation is a very unhappy one. Some other things to think about in this context are that there are lots of other consequences if there are nuclear explosions. For example, there's a lot of evidence that in many cases an electromagnetic pulse would be generated by substantial nuclear explosion. This was first noticed in the Pacific when at high altitude, while there were still tests in the atmosphere, a high altitude test a couple hundred miles above the Pacific was carried out, about 800 miles from Hawaii, and all the lights went out in Hawaii because the electromagnetic pulse, which was generated by the explosion, had dissolved much of the electronics. So this is a very serious problem, and no one knows much about it, of course, except what you can do by doing calculations. But it's very likely that that any serious nuclear exchange would lead to destroying almost all the communications in the Northern Hemisphere, for example, and including anything which was supposed to be of help in reining in the violence might well not be available. An even more serious matter is the nuclear winter question. You'll all recall that the dinosaurs disappeared when an object bumped into the Earth and threw up so much dust and debris that there was a nuclear winter. There was a winter. The sun couldn't get into the land, and the temperature was simply, 10 degrees too cold, something like that, for a period, several years. And the result was that the dinosaurs disappeared from the face of the Earth. And it could easily happen, and indeed there are many calculations which show that it can happen, that an exchange of nuclear weapons could lead to such a low temperature, to such a cloud of dust and smoke, that the sunlight wouldn't reach the Earth, and essentially crops would stop growing, and so presumably that would almost immediately kill almost everyone. And the calculations, there are varied calculations, they depend on all kinds of assumptions, but nevertheless, a lot of them are very discouraging and suggest that this is a very likely upshot of exchanges. The only other thing I'll mention before stopping is that, of course, there are many different treaties already in place. Outer Space Treaty, which says you can't have weapons in outer space, and so on. The biggest resistance to such things is usually the Americans, because they're pushing with new designs and so on, so they always want not to have their hands tied. For example, there is a test ban. There's a partial test ban for nuclear weapons. And it's partial because while it forbids testing in the atmosphere and in the oceans, it allows testing underground. And the Americans have occasionally voted for making it a comprehensive test ban, but their governments usually do not ratify such signatures. And so it appears that at the moment they're in fact designing some new weapons which will require testing, and so presumably that's going ahead in spite of this test ban. The other key effort is the Non-Proliferation Treaty. The idea was to keep there from being more and more nuclear states all the time. And to do that, the Nuclear Non-Proliferation Treaty was set up. But it's very difficult. The bargain, most of the nations of the world belong to this treaty, accept it, apparently. The bargain is that no one will start a new campaign of nuclear weapons on condition that those who already have them legally get rid of them. And this is written into Article 6 of this treaty. And it's been around for a long time. And the understanding is that the states and Russia and Britain, etc., should be dismantling their nuclear things in concert at the same time. And in fact, nothing has been done. For years that we've had this condition, and they aren't doing anything so far. Indeed, they're constantly inventing new weapons and designing them and growing them, as the United States is doing at this moment. And so that has not begun to succeed. Well, I better stop since the time.